Solve the following quadratic equations by completing square. P square minus 12p plus 32 is equal to 0. Solution. The given equation is p square minus 12p plus 32 is equal to 0. Shifting the constant term on the right hand side, we have p square minus 12p is equal to minus 32. Now, we will make LHS a perfect square by using third term is equal to half into coefficient of p whole bracket square is equal to half into minus 12 whole bracket square. 2 ones are 2 minus 6 are minus 12. And minus 6 whole square is equal to 36. Adding 36 on both the sides, we get p square minus 12p plus 36 is equal to minus 32 plus 36. Therefore, p square minus 12p plus 36 is equal to 4. Now, here p square minus 12p plus 36 on the left hand side is the square of p minus 6 and 4 is the square of 2. Therefore, p minus 6 whole square is equal to 2 square. Taking square root on both the sides, we get p minus 6 is equal to plus or minus 2. Therefore, p minus 6 is equal to 2 or p minus 6 is equal to minus 2. Therefore, p is equal to 2 plus 6, which is equal to 8, or p is equal to minus 2 plus 6, which is equal to 4. Therefore, 8 and 4 are the roots of given quadratic equation. Solve the following quadratic equations by completing square. X into in bracket x minus 1 is equal to 1. Solution. The given equation is x into in bracket x minus 1 is equal to 1. Opening the bracket, we have x square minus x is equal to 1. Now, we will make LHS a perfect square by using third term is equal to half into coefficient of x whole bracket square is equal to half into minus 1 whole bracket square is equal to minus 1 upon 2 whole square, which is equal to 1 upon 4. Now adding 1 upon 4 on both the sides, we get x square minus x plus 1 upon 4 is equal to 1 plus 1 upon 4. Therefore, x square minus x plus 1 upon 4 is equal to 5 upon 4. Now, x square minus x plus 1 upon 4 on left hand side is the square of x minus 1 upon 2. Therefore, x minus 1 upon 2 whole square is equal to root 5 upon 2 whole bracket square. Therefore, x minus 1 upon 2 is equal to plus or minus root 5 upon 2. Therefore, x is equal to 1 upon 2 plus or minus root 5 upon 2. Taking 2 as a common denominator, we have x is equal to 1 plus or minus root 5 upon 2. Therefore, x is equal to 1 plus root 5 upon 2, or x is equal to 1 minus root 5 upon 2. Therefore, 1 plus root 5 upon 2 and 1 minus root 5 upon 2 are the roots of the given quadratic equation. Four p square plus 7 is equal to 12p. Solution. The given equation is 4p square plus 7 is equal to 12p. After shifting the terms, we get 4p square minus 12p is equal to minus 7. Dividing both the sides by 4, we get p square minus 3p is equal to minus 7 upon 4. Now, we will make LHS a perfect square by using third term is equal to half into coefficient of p whole bracket square, which is equal to half into minus 3 whole bracket square is equal to minus 3 upon 2 whole square, which is equal to 9 upon 4. Adding 9 upon 4 on both the sides, we get p square minus 3p plus 9 upon 4 is equal to minus 7 upon 4 plus 9 upon 4. Therefore, p square minus 3p plus 9 upon 4 is equal to, taking 4 as a common denominator on right hand side, we have minus 7 plus 9 upon 4. Therefore, p square minus 3p plus 9 upon 4 is equal to 2 upon 4. Therefore, p square minus 3p plus 9 upon 4 is equal to 1 upon 2. Here, p square minus 3p plus 9 upon 4 on left hand side is the square of p minus 3 upon 2. Therefore, p minus 3 upon 2 whole square is equal to 1 upon root 2 whole square. Taking square root on both the sides, we get p minus 3 upon 2 is equal to plus or minus 1 upon root 2. Now, rationalizing the denominator on right hand side, we get p minus 3 upon 2 is equal to plus or minus 1 upon root 2 into root 2 upon root 2. Therefore, p minus 3 upon 2 is equal to plus or minus root 2 upon 2. Therefore, p is equal to 3 upon 2 plus or minus root 2 upon 2. Therefore, p is equal to, taking 2 as a common denominator, we have 3 plus or minus root 2 upon 2. Therefore, p is equal to 3 plus root 2 upon 2, or p is equal to 3 minus root 2 upon 2. Therefore, 3 plus root 2 upon 2 and 3 minus root 2 upon 2 are the roots of given quadratic equation. Two n square plus 5n plus 2 is equal to 0. Solution. The given equation is 2n square plus 5n plus 2 is equal to 0. Comparing this equation with the standard form ax square plus bx plus c is equal to 0, we have a is equal to 2, b is equal to 5 and c is equal to 2. By using the formula n is equal to minus b plus or minus under root b square minus 4ac upon 2a. Putting the values of a, b and c, we get n is equal to minus 5 plus or minus 5 square minus 4 into 2 into 2 upon 2 into 2 is equal to minus 5 plus or minus under root 25 minus 16 upon 4 is equal to minus 5 plus or minus root 9 upon 4. Therefore, n is equal to minus 5 plus or minus 3 upon 4. Therefore, n is equal to minus 5 plus 3 upon 4 or n is equal to minus 5 minus 3 upon 4. Therefore, n is equal to minus 2 upon 4, which is equal to minus 1 upon 2, or n is equal to minus 8 upon 4, which is equal to minus 2. Thus, minus 2 and minus 1 upon 2 are the roots of given quadratic equation. Three q square is equal to 2q plus 8. Solution. The given equation is 3q square is equal to 2q plus 8. Therefore, 3q square minus 2q minus 8 is equal to 0. Comparing this equation with the standard form ax square plus bx plus c is equal to 0, we have a is equal to 3, b is equal to minus 2 and c is equal to minus 8. Now, by using the formula q is equal to minus b plus or minus under root b square minus 4ac upon 2a, and putting the values of a, b and c, we get q is equal to minus in bracket minus 2 plus or minus under root minus 2 square minus 4 into 3 into minus 8 upon 2 into 3 is equal to 2 plus or minus under root 4 plus 96 upon 6 is equal to 2 plus or minus under root 100 upon 6 is equal to 2 plus or minus 10 upon 6. Taking out 2 common, we have q is equal to 2 in bracket 1 plus or minus 5 upon 6. 2 ones are 2 threes are 6. Therefore, q is equal to 1 plus or minus 5 upon 3. Therefore, q is equal to 1 plus 5 upon 3 or q is equal to 1 minus 5 upon 3. Therefore, q is equal to 6 upon 3, which is equal to 2, or q is equal to minus 4 upon 3. Therefore, 2 and minus 4 upon 3 are the roots of given quadratic equation. Seven p square minus 5p minus 2 is equal to 0. Solution. The given quadratic equation is 7p square minus 5p minus 2 is equal to 0. Comparing this equation with the standard form ax square plus bx plus c is equal to 0, we have a is equal to 7, b is equal to minus 5 and c is equal to minus 2. Now, by using the formula p is equal to minus b plus or minus under root b square minus 4ac upon 2a, and putting the value of a, b and c, we get p is equal to minus in bracket minus 5 plus or minus under root minus 5 square minus 4 into 7 into minus 2 upon 2 into 7 is equal to 5 plus or minus under root 25 plus 56 upon 14 is equal to 5 plus or minus under root 81 upon 14 is equal to 5 plus or minus 9 upon 14. Therefore, p is equal to 5 plus 9 upon 14 or p is equal to 5 minus 9 upon 14. Therefore, p is equal to 14 upon 14, which is equal to 1, or p is equal to minus 4 upon 14, which is equal to minus 2 upon 7. Therefore, 1 and minus 2 upon 7 are the roots of given quadratic equation. If the sum of the roots of the quadratic equation is 3 and sum of their cubes is 63, find the quadratic equation. Solution. Let alpha and beta be the roots of required quadratic equation. Therefore, as per given conditions, alpha plus beta is equal to 3 and alpha cube plus beta cube is equal to 63. Now, by using the formula a cube plus b cube is equal to a plus b whole cube minus 3ab into a plus b, we get alpha plus beta whole cube minus 3 alpha into beta into alpha plus beta is equal to 63. Now, substituting the values, we get 3 cube minus 3 alpha into beta into 3 is equal to 63. Therefore,
27
minus 9 alpha into beta is equal to 63. Therefore, minus 9 alpha into beta is equal to 63 minus
27.
Therefore, minus 9 alpha into beta is equal to 36. Therefore, alpha into beta is equal to 36 divided by minus 9, which is equal to
minus 4.
Therefore, the quadratic equation is x square minus alpha plus beta into x plus alpha beta is equal to 0. Substituting the values of alpha plus beta and alpha into beta, we get x square minus 3x plus in bracket
minus 4
is equal to 0. Therefore, x square minus 3x
minus 4
is equal to 0 is the required quadratic equation. X raised to 4 minus 3x square plus 2 is equal to 0. Solution. The given equation is x raised to 4 minus 3x square plus 2 is equal to 0. Let x square be equal to m. Therefore, m square minus 3m plus 2 is equal to 0. Splitting the middle term, we get m square minus 2m minus m plus 2 is equal to 0. Taking out m common from the first two terms, we have m in bracket m minus 2. And taking out minus 1 common from the next two terms, we have minus 1 in bracket m minus 2 is equal to 0. Therefore, m minus 2 into m minus 1 is equal to 0. Therefore, m minus 2 is equal to 0 or m minus 1 is equal to 0. Therefore, m is equal to 2 or m is equal to 1. Now, resubstituting m is equal to x square, we get x square is equal to 2 or x square is equal to 1. Taking square roots on both sides, we get x is equal to plus or minus root 2 or x is equal to plus or minus 1. Therefore, 1, minus 1, root 2 and minus root 2 are the roots of quadratic equation. The sum of the squares of two consecutive natural numbers is 113. Find the numbers. Solution. Let the two consecutive numbers be x and x plus 1. As per given condition, we have x square plus x plus 1 whole square is equal to 113. Therefore, x square plus 2x plus 1 is equal to 113. 2x square plus 2x plus 1 minus 113 is equal to 0. Therefore, 2x square plus 2x minus 112 is equal to 0. Dividing the equation by 2 on both the sides, we get x square plus x minus 56 is equal to 0. Now splitting the middle term plus x as 8x and minus 7x. We have x square plus 8x minus 7x minus 56 is equal to 0. Taking x common from the first two terms, we get x in bracket x plus 8. And taking out minus 7 common from the next two terms, we have minus 7 in bracket x plus 8 is equal to 0. Therefore, x plus 8 into x minus 7 is equal to 0. Therefore, x plus 8 is equal to 0 or x minus 7 is equal to 0. Therefore, x is equal to minus 8 or x is equal to 7. But we know that natural numbers are never negative. So, x is not equal to minus 8. Therefore, x is equal to 7. And x plus 1 is equal to 7 plus 1 is equal to 8. Therefore, the two consecutive natural numbers are 7 and 8. A natural number is greater than twice its square root by 3. Find the number. Solution. Let the natural number be x. According to the given condition, we get x is equal to 2 root x plus 3. Therefore, x minus 3 is equal to 2 root x. Squaring on both the sides, we get x minus 3 whole square is equal to 4x. Therefore, x square minus 6x plus 9 is equal to 4x. Therefore, x square minus 6x minus 4x plus 9 is equal to 0. Therefore, x square minus 10x plus 9 is equal to 0. Now splitting the middle term minus 10x as minus 9x and minus x, we get x square minus 9x minus x plus 9 is equal to 0. Taking out x common from the first two terms, we have x in bracket x minus 9. And taking out minus 1 common from the next two terms, we have minus 1 in bracket x minus 9 is equal to 0. Therefore, x minus 9 into x minus 1 is equal to 0. Therefore, x minus 9 is equal to 0 or x minus 1 is equal to 0. Therefore, x is equal to 9 or x is equal to 1. If x is equal to 1 but x is not equal to 1, as it does not satisfy the given condition, that is x is not equal to 2 root x plus 3. 1 is not equal to 2 root 1 plus 3. Therefore, x is equal to 9. Thus, the natural number is 9. A rectangular playground is 420 square meter. If its length is increased by 7 meters and breadth is decreased by 5 meters, the area remains the same. Find the length and breadth of the playground. Solution. Let length be L meters and breadth be B meters. According to given condition, length into breadth is equal to 420. Let this be equation number 1. Now, if the length is increased by 7 and breadth is decreased by 5 meters, the area remains the same. Therefore, we have L plus 7 into B minus 5 is equal to 420. Therefore, LB minus 5L plus 7B minus 35 is equal to 420. From equation 1, we know that LB is equal to 420. Putting this value, we get 420 minus 5L plus 7B minus 35 is equal to 420. $420 gets cancelled out on either sides and we have minus 5L plus 7B is equal to 35. Also, from equation 1, we can derive the value for length. That is, if LB is equal to 420, then L is equal to 420 divided by B. Using this value of L, we get minus 5 into 420 upon B plus 7B is equal to 35. Therefore, minus 2100 upon B plus 7B is equal to 35. Minus 2100 plus 7B square upon B is equal to 35. Therefore, 7B square minus 2100 is equal to 35B. Therefore, 7B square minus 35B minus 2100 is equal to 0. Dividing the equation by 7 on both the sides, we get B square minus 5B minus 300 is equal to 0. Splitting the middle term, we get b square minus 20b plus 15b minus 300 is equal to 0. Now taking out b common from the first two terms, we have b in bracket b minus 20. And taking out plus 15 common from the next two terms, we have plus 15 in bracket b minus 20 is equal to 0. Therefore, b minus 20 into b plus 15 is equal to 0. Therefore, b minus 20 is equal to 0 or b plus 15 is equal to 0. Therefore, b is equal to 20 or b is equal to minus 15. But we know that breadth can never be negative. Hence, b is not equal to minus 15. Therefore, b is equal to 20 meters. Putting the value of b in equation 1, we get 20L is equal to 420. Therefore, L is equal to 420 divided by 20, which is equal to 21 meters. Thus, the length and breadth of the playground is 21 meters and 20 meters respectively.
Form the quadratic equation whose roots are the square of the sum of the roots and square of the difference of the roots of the equation. 2x square plus 2 into bracket open m plus n bracket closed into x plus m square plus n square is equal to 0. Solution. Let us consider alpha and beta be the roots of the equation. 2x square plus 2 into, in the brackets, m plus n bracket closed into x plus m square plus n square is equal to 0. Then alpha plus beta would be equal to minus 2 into m plus n upon 2, which would be equal to minus into m plus n, and alpha into beta would be equal to m square minus n square upon 2. Let's put it as 1. Now the roots of the required equation are correct. Alpha plus beta whole square and alpha minus beta whole square. Now alpha plus beta whole square plus alpha minus beta whole square would be equal to 2 into alpha square plus beta square, which is further equal to 2 into bracket open alpha plus beta whole square minus 2 into alpha beta bracket closed, which is further equal to 2 into curly brackets minus into m plus n whole square minus 2 into m square plus n square upon 2 curly brackets closed. And we can say that from 1, which is further equal to 2 into curly brackets m plus n whole square minus m square plus n square curly brackets closed. This is further equal to 2 into brackets 2 into mn bracket closed, which is equal to 4mn. Let's put it as 2. Now alpha plus beta whole square into alpha minus beta whole square is equal to alpha plus beta whole square into brackets open alpha plus beta whole square minus 4 into alpha beta bracket closed. Once we put in the values, it would be m plus n whole square into bracket open m plus n whole square minus 4 into m square plus n square upon 2 bracket closed. Now this is further equal to m plus n whole square into bracket open m plus n whole square minus 2 into m square plus n square bracket closed. This is further equal to m plus n whole square into minus m square plus 2 into m into n minus n square. Well, it is further equal to minus m plus n whole square into m minus n whole square. So it is equal to minus into m square plus n square whole square. Let's put it as 3. Now, the required equation is x square minus sum of the roots into x plus product of the roots is equal to 0. So, from 2 and 3 we can say x square minus 4mnx minus m square minus n square whole square is equal to 0. Therefore, the required quadratic equation is x square minus 4mnx minus m square minus n square whole square is equal to 0.